talking you through to the approach that I used to solve the or design the FSM model of the problem of the vending machine that we discussed in class, the vending machine of Oreo and Kokomo. First, let's look at some of the basic things. So first of all, the state diagram. So how I have approached this problem is that uh, so there are three inputs. I've said that there are three inputs. There is I naught, there's I1, and there's I2. There are four states, the initial state, and then the state which shows like if 5 rupee coin is inserted, and then S2 which shows the when a 10 rupee note is inserted, and then S3 which deals all the cases of less than greater than equals to 15, right? And so the three inputs are I naught, which shows a 5 rupee coin is inserted, I1 which when it is 1 shows that a 10 rupee note is inserted, and I2 which deals with the type of product that the user wants. That is, if I2 is equals to 0, the machine dispenses Oreo. If I2 is equals to 1, machine dispenses Kokomo, right? So this is one of a state diagram similar to what we discussed in class, just that I've said that I've added these states. So when I2 is equal to 0, we'll go to this state and release Oreo. If it is 1, we'll release Kokomo and go to this state, right? And then these both will go to this initial reset state. Going on to the transition table now, how I've handled that here is that I've taken two outputs, right? So the final our final output is a Kokomo or Oreo dispensing or releasing from the vending machine, right? So I've taken two variables y, z. So I've said that when y is equals to 1, we should give the user Oreo. When if z is equal to 1, we should give the user Kokomo, right? And so here you'll see in this row where I2 is equals to 0, I2 is equals to 0, you see y is equals to 1, because we have said previously that when I2 is equals to 0, we should release Oreo, and here y is equals to 1 means dispense Oreo. So here y is 1, z is 0. And in the last row, when I2 is equals to 1, we see that y is 0 and z is 1, and so we dispense Kokomo. And for all the other cases, I've taken I2 don't care here, as you can see, because we only care about the final output once we are in the final state. So हमारी जो final state है वो है S3, जिसमें we handle the greater than equal to 15 wala case in terms of money. So at that point we'll decide what user wants or what user has said to give him or her, and accordingly we'll release Kokomo or Oreo. So that's why these I2 in on these states is not necessary. It's only necessary at the end. So I have written it here only at the end when we are at S3. So 0 means Oreo, and 1 means Kokomo, and that's why and the outputs are accordingly y and z, right? And I've done one more assumption, that when both inputs are 1, so when I2 and I naught both are 1, I've also then taken don't care because I'm assuming that user will will not give to a 10 rupee note and a 5 rupee coin simultaneously. It will give after some break. So that's why. Moving forward, then I have encoded state table where I have denoted next states by A star and B star, and these are my outputs. As you can see, these are the inputs and the present states, S0, 1, S2, S3, right? And these are the three inputs, and I've denoted the next A star and B star. And then finally I came up with the equations of the next states: A star, which is basically AT plus 1 for the B star, and y, which is the final output, which will tell us y and z, which will tell us that whether we'll give Oreo or whether we'll give Kokomo, right? Now coming on to the simulation part. So here I design it on the logic.ly. So here there are these three switches, right? I naught, I1, I2. So these I naught, I1, I2. These three switches are shows three inputs, and these two bulbs means which if the bulb which will glow means that object or that item is dispensed. So as you can see, when we'll click both I naught, I1, these both are blue. I2 is 0, right? We have not clicked it, so it releases Oreo as discussed in the logic that we have discussed right now. When I turn this I2 on, it will automatically switch to cocomo, because we said that when I2 is equals to 1 means when it's glowing, when it's blue, we release cocomo, right? And these both are basically IO0, and IO1 deals the money with the money logic, and this these with the product logic. So you can see if when it's off, it dispenses, and it shows a root here. It dispenses Oreo. When it's on, it dispenses Kokomo. I've used two D flip-flops to implement this logic. And if I turn off both these things, then you can see none of the bulb will light, right? And when I'll switch on these both, I2 is 0, so automatically it's Oreo. If I turn this on, it'll dispense Kokomo. Okay, so this is and these are the gates are basically, these are I extracted from the Carnot map. So I've designed the gates according to that. I've also put a clock here which is connected to both the clocks of the D flip-flops, and accordingly. So yeah, that's it.